Hey everybody, how's it going? Hope you're having a lovely day. So one of the topics in this channel over the past 10 years is that many Apple products suck. Their engineering is horrible and they are made in a manner where they fail in a way that most other products just don't fail. And I'm here today in March of 2023 to tell you that this is still true. Apple products still suck and they still fail for ridiculous reasons. Here we're going to be going over a very, very common failure on the A1990 and A2141 MacBook Pros that I talked about in last year's video, where we went over the fact that they will just randomly decide to send 7 to 12 volts to your storage. Before you call me a senseless Apple basher, I just want you to think about this. I want you to go through a list of all the products that you own, all the different computer motherboards, laptop motherboards, brands, and honestly tell me, how many of them do you know that fail in this way, where they send 7 to 12 volts to the device that has all of your storage, and icing on the cake makes it so that it is not modular, so that when it sends 12 volts to your SSD, you can't even replace it. That's Apple engineering. I don't do the board repairs here anymore. Chris does. So I will let him take this one and, well, you'll see. This is something that we get now about 2 or 3 times a day for the past 3 months. We have gotten at least 100 of these and had to tell the customer, I'm sorry, there's nothing I can do for you. Sometimes they'll push back and go, why can't you recover my data? So we are doing this video so that we have something to link people to. It is not our fault that your computer sends 7 volts or 12 volts to the chip that has all of your data. That is Apple's. And if they have any sense of customer loyalty, what they will do is they will put together an extended warranty program for all of these people who have had their SSD fried by a motherboard that decided for no good reason, no liquid damage, no drop damage, no abuse, that it was just going to send triple or quadruple the voltage that that NAND is rated for to it for no good reason.
Today I have for you a 1990. I start to working on it and then I realized I pressed the wrong button, so I didn't record it. Let me show you what the board does. So the board stuck on 20 volts and 70 milliamps before. Actually, those readings tell me something is wrong with the SSD area. I didn't check what is wrong with it, but I just noticed there is the whole area is really clean except that thing. I tried to actually take that cover and see what is wrong with the SSD, but nothing is wrong here. I didn't do any measurements before. So let's take the board out and see what is on the other side of the board. Yeah, like you can see, the board is actually clean. It's a little bit dusty, but it's nothing bad. So let's check everything from the beginning first. First, what we have to check, it's a resistance to ground on those 2 coils here. It's 90 ohms right now. I try to turning on the board, so those readings are always like that after plug it in. Like you can see, it's you can't see. It's going up, so the next thing what we have to check, it's a voltage. It's a voltage on those lines. So you have to check voltages from the ocarina. It should be 0.9 and I think 1.8. Yeah, so we have 0.9 here, or 0 right now. Yeah, it's jumping, or I didn't maybe press it. Yeah, it's a 1.8 and 2 lines with 0.9. The last rail is 2.5. Come on. And you have and we have 7 volts on 2.5 volts rail. You see? 7 volts. Welcome in Apple world. Okay, so actually the SSD is dead here. So you asked me in the comments below the last video why we can't recover data from the Apple SSDs. This is the perfect example how we can recover data from the drive where you should have 2.5 volts on the NAND rail and you're getting 7 volts. Right now I'm gonna take that back converter off and I'm gonna try to show you and check if there is any liquid or there is a corrosion or something. Okay, so coin. Even right now we don't want to overheat the NANDs. Fume extractor. Look how clean that chip is. Nothing, no dust, no corrosion. So what could happen? Let's go to the schematic. So this is that side of the board. This is this guy here. So right now we can't blame moisture, the liquid or anything because look, this back converter has two lines here. Here is PP bus, here P bus is coming here. So this row of the balls, it's a P bus. The second row, it's two switches, two rails which going straight to the NAND. Look, it's going to the all of the NANDs here. So what could happen here? Take a look at this schematic. Probably something like an internal diode MOSFET, some internal component in that TPS. TPS 62180 failed and sent 7 volts to the 2.5 volts rail. Of course, I'm gonna try to replace it because I have to try, but probably the SSD is gonna be dead. So first, what we want to do here, we want to clean the pads from the old solder. We're gonna use leaded solder. Okay, this is it. This is our chip. New chip actually. Nice and easy. Okay, let's check the orientation because of course I forgot. Okay, so the first ball should be there. It's actually perfect example for it, how the SSD are dying here. One of the reasons is actually that chip, that back converter. Let's check. Now, "20 volts, 80 milliamps like it was before." And the voltage is still 7.5, so it wasn't the back converter right now. That's interesting. Let's go back to our schematic. What could happen here? Enable. Feedback. Let's check the feedback. Okay. This is okay as well. Okay, let's take the donor board. Oh, what's up? Oh, okay. Yeah, so magic trick. 7 volts on 2.5 volts SSD array.
That's good.
Yeah, it's very good. I'm gonna replace the whole neighborhood here, just in case, because I don't like to leave the case like that. I want to make some room for me, some space. Shit, what is going on with my hands today? Not enough coffee, I think. Piece of resistor. Okay. Quick look to the schematic again. So what do we have here? We have 2.5 on those. Okay. Let's clean it and let's see if we have still 7 volts or 2.5 volts there. Volt 70 milliamps, 45. Okay, so something changed. 2.5, like you can see, like you can't see. 2.5. Come on. Come on, you 2.5. Yeah, 2.5. And let's see what the board does. If we are lucky, but I don't think so. The board might be in the recovery mode right now, but actually I'm, how to call it, hopeless. Yeah, Apple engineering. Yeah. So even the Apple software is like buggy. The worst part is right now we have to restart the whole machine. I don't know why it works like that. It's actually a waste of time. Yeah, so we're guys paying Nadui P50. So you guys paying thousands of dollars and you're getting buggy software, you're getting ICs like that, then you're losing your data. No, actually we are not that lucky. But we can try to force DFU. Oh, we can try to force DFU, revive it, and then we're gonna be actually sure if something is wrong or not. I have to be sure. Since the board sent 7 volts to the NANDs, it's gonna be trash.
Yeah, the audio works just fine on that. Like yesterday when I turned it on, this is gonna be a whole piece of yeah, something like this. I would start guessing. Buying and what I see is probably easier than buying a proprietary something. Yeah, it's not what dude, I'm not.
We have to plug everything in. Maybe we don't need an audio board, actually audio jack here, but I like to be sure everything is plugged in. I don't know if you know, but we can force the DFU here. We have a jumpers here. How to do that? Let me show you on the schematic again. I have to find my keyboard. I'm losing everything today. I know it's a Friday, so I can't wait for an evening. Oh, this is that camera. So our jumper to forcing DFU is here. You see? This is this one. SWK003. This is that button for force DFU. You have the second button actually here. This is power button. Like if you like it, you can use that. If you don't have actually power button, plug it in. You can turn on your board here. So let's back to our laptop. You have to use that port always. It's a master port. Right now we're gonna short the pins. Yeah, like you can see. I hope you can see. The T2 is in DFU mode right now. And let's try to revive it. So from here, advanced and revive. It's good to plug the charger in. Yeah, if it's running so fast, it means the actually SSD is dead, most likely. I never had that issue when it's reviving device so quickly and then everything's gonna be working again. Most likely it's gonna take some time. It's like 3-5 minutes procedure. Let's try again. Yeah, like you can see the software froze again. You see? Yeah, so right now we have to force quit. Yeah, so we can't do anything here. This is how the Apple's SSD are dying, most likely. You have also different SSDs, for example, in A1466 or A1502s. There is a different issue. You don't have that back converter, of course. The SSD are not soldered into the board on those machines, but there we have to deal with serious firmware issues which we can't solve because we don't have access to the save mode on those drives. We don't have a firmwares for those drives. So actually where the service area is damaged there, we don't have access to that data. So that's it for today, and like always, I hope you learned something. Take care.
Let me know what you think in the comments down below. That's it for today, and as always, I hope you learned something. Bye now.